So my name is Baljesh Mehmi from Altair, and I've got my laptop here as well because I couldn't quite see the notes on the screen, so my eyesight's going a bit bad. We're on stand A7, A9 downstairs, and we have a workshop which my colleague will be doing, showcasing some of the technologies that I'm going to refer to in today's presentation. So that's accelerating product design, and if you just go out the door, and it's left and left again, and you can see some of those live. And I just want to thank the previous speakers and in terms of setting the scene. So my talk's slightly different. I'm going to be introducing some new concepts in the simulation-driven design process, refer to generative design, and also how data leveraging data can impact your design very early on in the design process. And I think someone mentioned it earlier. It is all about speed. We need to get these products developed really fast. They're becoming ever more complex, and the technologies need to help in that speed process. So without further ado, a quick marketing video.
The conventional wisdom says that to achieve something new, we must work within established boundaries, parameters, silos. That the size of an idea is determined by how much it pushes its limits. So what happens when there are no boundaries? What happens when the barriers separating creativity from analysis are removed? When we can refine ideas as quickly as we dream them? When insights emerge from an ever-growing sea of detail? What happens when we're no longer constrained by the limits of the physical world? We are Altair, and these are the questions that drive us. To bring together the most powerful forces in technology, across every domain of humanity, throughout every mode of industry, we enable innovative minds to advance infinitely, to change tomorrow, together, to find out where innovation will take us, when instead of testing the limits, we remove them.
So I think at Altair, we believe we are the leaders in computational science. When Altair began back in 1985, we had a suite of simulation tools, and those simulation tools were predominantly being used to replace physical testing. But as HPC, high performance computing, got more affordable, our solutions became more affordable in terms of the value they bring to our customers. We saw a drive to use simulation just to impact the design. And now what we're seeing at this moment in time is how data analytics and the application of that in our space can further impact that design through AI. So today we refer to that as the convergence of HPC, data, and simulation. A bit about Altair. So we've been, this is from 2017. Over $500 million turnover, rapidly growing. I think we've got 86 offices, growing every day through acquisition. And I think our three super regions, EMEA, APAC, Americas, are all equally sized in terms of revenue. Quick snapshot of our customers. So we've got automotive, which is our largest, followed by aerospace, financial services, and technologies that you can see there. I'll come back onto financial services because I think that seems a bit strange for a simulation software company to have a financial services arm in there. But a lot of the acquisitions that we'll see shortly are technologies used by the banks, where they're using AI, machine learning, a lot of data analytics for data prep, and we're trying to bring those technologies into the hands of the engineer because they will be very powerful. So we're working obviously with quite a few big brands, and we've got some case studies, a snapshot of case studies which are all online, looking at AEC, electronics, automotive, and I just want to give you a quick snapshot of some examples of AI and machine learning with some of our customers. All right. The first one being BMW. So BMW using machine-based learning, so something that we've developed called clustering. So clustering the designs and allowing the customer to get to an optimum faster. So we'll see that in an example later on. Jaguar Land Rover, using machine learning and text analytics to take warranty data and automatically bin it, so engineers can spend their time focused on the issues that the customer actually needs fixing. All right? Marbe using data analytics to predict future failures in their products. And I think we see more of our customers looking to leverage data, and I think it's such a powerful resource to have. It's just getting access to it very, very quickly and at the right time. And I think speaking with some of our big automotive clients and the engineering director, the thing that he said, it's all about fueling the engineer. If you can fuel the engineer with the right data at the right time, it'll become a very powerful combination. So how has this been achieved? Through obviously 32 products developed in-house and 46 products through acquisition. I don't want to go through all of them. I just want to highlight a couple. So thanks for Bradley for introducing obviously the concept of implicit geometry. Obviously, from a simulation world, it means a different thing entirely. But for us in the simulation CAD world, you know what that means. And I think it's great that we've acquired Gen 3D, which brings Sueless Flow and Sueless Lattice into the portfolio of the Inspire technology. And I think going back to that speed topic, it is all about speed. If you've got really complex geometry that can be represented by an equation, that is really, really powerful. And I think we've got Wesley from Gen 3D here as well somewhere, and he'll be on our stand if we need any more information. Secondly, Rapid Miner, and again, so this is a data analytics platform, and this was recently announced a couple of months back, and this has over 1 million users worldwide taking data and trying to make better informed decisions using that data. All right, so we want to get these tools into the hands of the engineer and give them the tools to make better informed decisions with the products they're designing. Because not in all cases is simulation required. It may be that the data is already there to help you make a better informed decision. So why Altair? And I think just some 6 points of obviously best-in-class analytics and AI solutions, global domain simulation expertise. I think I'll give you a quick run-through of Altair's history in optimization in the next couple of slides. Leader in HPC technology and open architecture. And I think anyone that's interested, that wants to learn more about our licensing model, which is unique and it's a patented licensing model, you can go and take a look at altair.com/altair-units. And then I think you'll be, everything that you see in terms of the technology is all accessible under the one umbrella. And everything that you'll see in my colleague's workshop by Chris, everything is already in the technology, ready to go. And there's no additional features or licenses required. Right, now this is the main part of my presentation, because that's the Altair bit done. So this is our complete portfolio, and like I said, it's available under that single license file. And I'm going to focus in on simulation-driven design, all right? And these are the solutions available to the designer responsible for design for manufacture, the engineer. They can take these tools, use them. They're really easy to use, and some are systems tools. So you got maths tools. You got a block diagram tool, and you've got this tool here called SimSolid, which is a meshless simulation tool. So really, really fast. And anyone doing CAD that just wants to see if their designs are going to work or not can bring their geometry into that solution, and it'll give you a result in the matter of minutes. And you don't need to have a lengthy training course on how to do simulation. And the tools in there, obviously, looking at printing, casting, injection molding, foaming, stamping, extrusion, and they're all available under that Inspire tool, which I'm going to talk to you a bit more about now. So Inspire is what Chris is going to demonstrate next door, And all of these generative design tools that I'm going to talk about now are all available within that platform. Okay. So generative design, and I think we heard one of the team present that from the Dassault this morning. And I think for us, we see generative design as a collection of tools to allow engineers, designers to produce products ready for manufacture. And that's bringing together simulation, HPC, and data. So, you know, validated, ready to go products. Now, why is this so important? All right. Now, this is a bit of a snapshot of through time of the evolution of simulation. And I think, like I said at the start, simulation was predominantly used back in the early 1980s to replace test, because test was really, really expensive. All right. And as you move along here, we saw more and more use of simulation, less reliance on test. So, and I think that's fine, because, you know, you can reduce cost in terms of your product development. But one thing that wasn't being done with the simulation and the advent of HPC was using simulation to actually impact your design and drive your design. So in the early 2000s, Altair developed a technology called OptiStruct, and it gave OptiStruct to the CA analysts at that time to start using simulation to impact the design. All right. So what you're trying to do now is use simulation to drive the CAD. All right. So back then in the early 2000s, it was probably predominantly gauge optimization, where you're playing around with the gauges of your body in white and so on. And then since then, we've developed a lot more solutions, and badging those under the framework of generative design, which we'll see in a second, and then bringing in data. They're all geared about getting your product developed significantly faster and making sure it is really, really robust and best for market. The key, I keep having to emphasize the term, the key is speed. All right. You don't want simulation falling behind your design. You want simulation to be driving your design. All right. So just oops. So just that evolution. So back in OptiStruct, back in 1990, where we launched OptiStruct, and again, it was a really disruptive tool, because it was like Bradley showed you, coming up with really organic shapes that people were saying can't be made. And then I think we started introducing manufacturing constraints so they could be made. Adding in more features, adding in composites, adding in lattices, CFD responses for your thermal, and then some of the technologies I'm going to talk about, shape, physics, and expert AI. And these are some of the brands that have been with us on that journey, okay? And they're still using the technology today, which is fantastic. Right, so generative design, we see that as a framework of three areas. So number one, optimization, like you've seen already. Whether it be topology optimization, where you're trying to take away as much material as possible. Topography optimization, where you're trying to increase the stiffness of your part and your model frequencies, and maybe size of shape, and there's a lot more in there. Design exploration, so coming up with doing DOEs, looking at data, process automation. There may be several geometries that or designs that may do the job that you need, and which one is the best one. And do you need to consider manufacturing in that process? And we'll see an example there. And finally, AI. So AI and data-driven design. So data mining, predictive models, and machine learning. And all of these three things will help you design a better product. So these little bubbles should still appear at the top. Okay. So this is my only slide on just focused on optimization, and I think this was work done back on the A380 wing ribs, which were designed using OptiStruct. Took out, I think, 3 tons in total out of the weight of the wings, and optimizing metals, plastics, and rubbers, and some work done by Renault Trucks to take out, which is, I don't know, old school engineering now, isn't it, an internal combustion engine. 120 kilograms out of that engine. And I think optimization is injects innovation into your products, but ultimately you've got to be able to make these parts, and I think that's where a lot of these manufacturing constraints come into in terms of being able to make the part. So design exploration, and I think I've been here whereby you do a simulation, you look at some data, then you review the results, and you may go again, and you just keep going. And I think one of the things that you want to try to do, and now you can do because the technology's there, the HPC's there, the licenses are there, is do design exploration. And why you want to do design exploration is you want to see what parts of your design influence each other. And then I think it's such a powerful solution to be able to see that complete space that your design could sit in. And once you can see that space that your design can sit in, you can start looking at optimization. Okay, so this actually, you could say this sits before the optimization piece where you're just trying to explore your design. And again, this is all single solver, single physics, multi-physics enabled. So what could you potentially get out of that? You can, from your design experiments, from historical data that you will have sat within your organization, you can start doing machine learning. You can start doing scalar predictions, looking at key performance indicators. You can start doing field predictions, curve predictions, and the BMW use case was using design clustering. So here's an example of some design exploration. Again, another simple bracket and the various designs that could be produced by the technology, and then the different stress contours based on the design. And I think the power of that Inspire suite is that not only it can do this and the design exploration, you can start looking at the actual, taking into consideration the manufacturing process, all right? So you've got hybrid casting, bonded jet, desktop metal, traditional milling, traditional casting, and then metal desktop printing. And I think ultimately you've got to be able to produce the part. And I think being able to simulate that process as well, whether it be cast, sheet metal formed or printed, is what you ultimately need as a designer to be able to do, to confidently say that this geometry is going to work. And I think this just shows the process of that time saving that could be achieved. So there's that final bracket that was produced. And then in the same solution, you can bring it in and actually do the dynamic simulation and see it in its real place in that geometry. And then obviously just find the final printed parts that were produced, I think, on a Renshaw machine. And finally, the AI piece. The artificial intelligence, and I think we can break that up into physics AI, shape AI, and this expert AI, and I think this is where we feel the next evolution of the tools is, and again these are all already available in the tool sets within the HyperWorks suite. So shape AI, and again, I think if you're from a CAD environment, this is nothing new in terms of your model, your database, auto machine learning, doing searches to find similar parts, identify parts and so on. But I think the new part is that by finding those, maybe you could do a bit of try to inject some innovation in there. And I think the most recent use case was the semiconductors, in terms of trying to find which semiconductors your vehicle's using, and could you get away with using some different semiconductors in different areas, or use the same semiconductor in a different areas. And I think it's a very powerful tool that we've basically added to all our products, because everyone's bringing in geometry, which is of similar nature. So physics-based AI. So in this example, what we've done is do like a design of experiments. All right. So we've done a DOE on this B post, and this is looking at intrusion on the B post, and we've come up with our response surface and brought it into Design Explorer, and now we've got these little dials that we can play around with, all right, which can be seen here. So we could start playing around with the thicknesses of the parts, and then change the thickness and do a predict. And that prediction is basically interpolating the results between those two designs to give you a new prediction. And I think the BAC presentation this morning talked about the importance of customizing your product for your customer. Wouldn't it be great once you've measured your customer up, that you can quickly generate a brand new design which is already fully validated, because it's already got the extremes of the response surface built into the use case. So this is basically a prediction, okay? So we've not run anything new here. No, there's no simulation been done or no new analysis. We're just interpolating the results from the two extremes based on these variables that we've injected. So that's physics based on expert AI. So this is that process of this referred to, is that we've done our DOE, we've come up with some results, we've come up with our response surface, and then we can do an optimization. Okay. Now, this is a simulation of a front longitudinal, right? And what we've tried to do here is look at modes of failure and have the engineer, all right, so some of you and you're in this room, is to tell the physics-based expert AI that I want my mode of failure to be a particular shape. Okay, so we're now telling, using machine learning to tell that solution that I want to see this shape. And what tends to happen is you've put 3 shapes in, your DOE response surface now looks like this. Okay, so these are the different responses based on these shapes from your design. Now, as an engineer, you may want this mode of failure because that's what you want to see based on your criteria or your targets. Now, what that means is, once you know that defined shape, you can actually get to your optimization, your optimized product a lot earlier. And that is essentially what BMW were able to achieve. They were able to engineer their product in a significantly short amount of time by using design clustering. Okay, and this is that design clustering, which I can show you here, whereby we've got our analysis set up. We've got various results coming out based on 2 or 3 design clusters, and then we're basically using these clusters based on an input that we've put in, and there you can see the different runs in there. Okay, so this is obviously a solution from the automotive industry, but other applications for this is antenna design, where you're trying to get a certain performance out of your antenna. So you can give instead of giving a shape, you can give a result output that you want and allow the technology to come back to you with a fully designed antenna. And other areas whereby you may be looking at, from your manufacturing process, you want thinning or certain properties in your pressed part in a certain area for other performance characteristics. And again, this process will tell you the optimum solution a lot faster because you're giving it effectively like a head start. Oops. So that's generative design, and I think we have that in those 3 areas. Optimization, design exploration, and this AI piece, and all again built into that Inspire solution. Okay, and I think one of the things that we had our team in the US do, and I think third party ran a what was it called? A ranking by ABI Research in the US, ranking some of these technologies, and I think it was a testament that Altair, I think, came up top in that solution for their generative design technology, because it is a complete solution. And you can all see it live and try it for yourselves in the workshop. We're actually starting now, so I better be quick. So just to this is my final slide, and I just want to remind everyone about these things. So I think the technology obviously is as a backbone of being geometry based. It's designer friendly, and I think that is key, because I think with the designers you've got to be able to come back after a couple of weeks and be able to use the same tool. And I think Inspire is so intuitive to use that I think everybody should be able to use it. Generative design, so bringing in those three areas that I mentioned, the optimization, the design exploration, and the AI is all built into that solution. Then finally, being able to confidently say that you can actually make the part based on your manufacturing process, and I think that's where the manufacturing part of it comes in. So yeah, that's my final slide, and I just want to obviously the extensible open architecture, which is the last piece on that. And just want to thank everyone for listening, and I hope you found it useful.